For years, alternative proteins like plant-based burgers, cultivated meats, and precision fermentation were framed as a consumer dietary trend or a niche experiment for venture capitalists. To most, they were a Silicon Valley curiosity rather than a global necessity. But by 2025, global supply chains began seizing up. A cascade of new trade barriers, compounded by severe weather events, locked down major ports and choked off the flow of goods across borders. Traditional agriculture, which relies on the complex international movement of feed, fertilizer, and livestock, proved highly sensitive to these disruptions. A localized drought or a sudden tariff dispute could suddenly threaten the food supply of nations thousands of miles away. Governments identified a massive blind spot. Traditional food systems had become a national security vulnerability. Depending on highly distributed, fragile trade routes, left their populations exposed to events completely outside of their control. To protect their citizens, nations started pivoting their strategic planning. They began treating alternative protein sources as a domestic backup plan, a way to guarantee food security when international shipping lines fail. As nations begin funding shared biomanufacturing facilities and integrating proteins into their national biotechnology strategies, these technologies are taking on a new role. They are becoming the infrastructure used to stabilize domestic economies during global shocks. This new infrastructure is built on three main production pillars: advanced plant-based innovations, cultivated meat grown directly from animal cells, and precision fermentation, which uses microbes to brew specific proteins. Behind the scenes in 2025, scientists achieved massive cost reductions across all three methods. The shift from experimental R&D to active commercial regulation means the necessary framework for a global, safe, and viable market is now operational. With the safety proven and the technology maturing, a global financial race has begun. Major world powers are actively competing to scale these production facilities before their neighbors do. China has adopted an aggressive strategy to lead this sector. A state-owned development corporation earmarked nearly $1 billion specifically to build out biotechnology facilities, prioritizing food applications. The European Union took a different path to achieve a similar goal, awarding over €100 million in targeted loans to help domestic plant-based and fermentation companies scale up their operations. Other major economies are matching this pace. India rolled out its Bio-E3 policy to fund smart protein research, while countries like Canada are investing in technologies that convert local agricultural side streams, parts of crops usually thrown away, into high-value protein ingredients. Intrigued tone. There is a highly strategic reason governments want these specific facilities inside their borders. These plants are designed as flexible biomanufacturing hubs. During peacetime, these massive tanks stay operational by producing popular high-volume food products. This continuous operation pays for the facility and keeps a specialized, trained workforce on staff year-round. But if a severe global crisis hits, that exact same infrastructure can be rapidly reprogrammed. Instead of brewing food proteins, the facility can pivot to mass-produce critical medicines, industrial chemicals, or emergency materials. Investing in alternative proteins allows a country to build a scalable, crisis-ready biodefense system supported by consistent consumer food sales. Despite the technological milestones and the clear strategic benefits seen in 2025, the sector is hitting a severe funding bottleneck. This chart shows the financial requirement to secure our global food system through alternative proteins. Analysts estimate it requires $10.1 billion annually to reach maturity. However, current government investments amount to roughly 10% of that benchmark. The need remains unmet. Closing that 90% gap would generate massive economic and environmental returns. Fully scaled alternative protein sectors are projected to create up to 9.8 million new jobs and add $1 trillion in economic value. The underlying science is proven, and the resulting consumer products meet strict safety regulations. More importantly, building out this physical infrastructure acts as an insurance policy against future global shocks. The production methods are proven and the safety standards are in place. The transition to a more resilient food system now depends on whether governments allocate the capital required to build it.